And do it like this, so remove the class from 0 and add it to player 1. But there is a better way, because we not only have remove and add, but we also have something called toggle. And what toggle does is to add the class if it's not there, and if it's there, to remove. So in this case, if player 0 has the class active, then it will remove it, and if it does not, then it will add it. Alright, so I will leave these here as your reference, okay, but I will now do it differently. Okay, so I don't want to remove, I want to toggle. And here the same thing. And now it's going to work. Alright, so it changed to player 2 and it changed back to player 1. Alright. Okay, very nice. And now one last thing that I want to do is to also, when a player rolls a 1, to hide the dice again. So that when the next player's turn is, we don't have any dice here visible. And that's pretty easy, we already did that, right? But without looking at the code, we know that it's document query selector, and it's the dice class actually. And then we need style, and then we just need the CSS property that we want to change. And this one is the display property, which we are setting to none once again. Alright. So let's reload this. Alright. So I rolled a 1, but it disappeared, and now it's the next player, and he has like an empty spot here to roll his dice. Now up until this point, we have no way to hold our points so that they get added up here in the global score, right? So that's what we're going to do right in the next lecture. In this lecture, we are going to implement our hold function and also talk a little bit about the don't repeat yourself principle. So we will continue using the concepts that we have been learned so far, and we will also learn how to use functions to correctly apply the don't repeat yourself principle. And of course, we will continue thinking about the game like a real programmer. So let's do that. So this is where we left after the last lecture. So far we can roll the dice and add our scores down here, but there's no way to hold our points and update our scores here in the interface. So let's now do that. So once again, we are going to set up an event listener, and this time it's going to be for the other button. So let's check out which one that is, and it's called button hold. Alright. So let's start by selecting it, and by now you already know how to do that. So query selector and then button hold, and then add event listener. Okay, and we want this to happen on the click once more, and we're going to use an anonymous function, which, as you remember, is a function which doesn't have a name and that we cannot reuse in another point of our code. Okay, so we simply write function like this, and we have no parameters, and now in here we can write our function body. So let's first define what we want to happen as soon as the user clicks the hold button. So the most obvious thing is, of course, to add the current score to the player's global score, right? So once again, I'm using these comments here to first define what we're going to do and then fill it with the code. So add current score to global score. Then we of course want to update the UI, the user interface. And there is another thing that we can and should do right here in this function, so when the user clicks the hold button, which is to check if the player won the game. So let's add that here too. Check if player won the game. So once again, when we hit the button, then the score that we have in that round gets added to our current score. Then we print that number to the user interface, which means that we perform some DOM manipulation. And then after that, we check if the player won the game. So let's start right here. So this one should be easy, right? Remember that right in the beginning, right in the first lecture, we created this variable here which stores the scores for both the players. And that we also have this variable here which stores the active player. So player number 1 is 0 and player number 2 is 1. And we can now use this variable to access, to read or to write, in this case, the scores right into this array. So if the first player is the active player, then this is 0, and so we can say scores 0, and then we will have the value in here. And if the second player is the active player, then this is number 1, and then scores 1 is this element. So let's now do that. So scores, and we use the curly brackets to access the variables or to mutate it. And now we simply have to write active player, right? And what will this score actually be? We will simply add the score that the player got in this round to the score that the player already had. So it's as simple as this, so plus equal the round score. And remember that this works because this is the exact same thing as working it like this. So active player equals the score that the player already had and plus the score that we got in this very round score. Alright, so this is the exact same thing, but once again I prefer to use it this way here, okay? So I'm just going to delete this, just wanted to show you that this is the exact same. So I hope that makes sense. Now we want to update the UI, and in order to do that, we first need to know where we have to write our data. So it's here in this ID score 0 for player 0 and score 1 for player 1. So let's do that here with document.querySelector score. And then we're once again going to use our simple trick where we use the active player variable to construct our string name here, basically. So active player like this, so that we don't have to specifically write score 0 or score 1. And here we just missed this, and now we're good to go. So we have our active player score selected in the user interface, so let's now change the content. And if you remember from the last lectures, we use that simply using the text content method. All right. And what are we going to print here? It's simply the value that we defined before. So we go in our scores array once again, and then select the points from the active player. So if it's the first player, it will be the first element of the array. And if it's the second player, then it's going to be the second element of the array. So let's check out if this is working as intended. So I roll the dice and I hit hold, and alright, here we go. So we have 8 points now here. Now what isn't happening here is that it isn't changing the active player. Because remember, when we hit the hold button, we store our points and then it's the next player's turn. But that's not happening right now. So we have to implement this right now. And you probably remember that we did exactly that in the last lecture, right? Because it's exactly that happens when the user rolls a 1, right? So basically after the user rolls a 1 and after the user chooses to hold his points, it's always the next player's turn. So it's the exact same code, so we can just copy this down here to our other function. Now this doesn't make much sense, does it? Why should we have the exact same code in two places of our application? Imagine that we have to change something here, for example, I don't know, this class name here or some of these class names, and then we also would have to change it up here. So this is very difficult to maintain, and it's not a good practice at all. In fact, it's a really bad practice. And that's why there's something called the don't repeat yourself or DRY principle. Of course, as the name says, that we should not repeat ourselves in our code. So what can we do in order to apply the don't repeat yourself principle? You guessed it, we are going to implement a brand new function. And this one is going to be called next player. So function next player. And now we're just going to paste this code here, and we have our function. So it's a function that doesn't receive any parameters, and it also doesn't return any result. We simply use this function in order to not repeat our code. So we defined the function, and now we can actually use it. So we are going to delete all of this and simply call next player. And then of course the same thing here. So deleting all of this and next player. And just like this, we use the DRY principle. So this is something really important in programming in general. So let's check out if this works. So holding, and alright. So we're back to 0 here. We have updated our score here, and player 2 is now active. And we keep rolling the dice. So we have 5 and 6, so we should have 11 as soon as we hit the button. And alright, it's working. Great. Oh, rolling a lot of ones here. Yep, so it's working on both sides, right? So let's go back. Now there's only this thing here to do, which is to check if the player has won the game. So let's just check out the rules of the game, which says that the first player to reach 100 points on global score wins the game. So this should be pretty easy, right? So can you guess what we're going to do here? Take a moment and try to actually implement this for yourself, okay? So pause the video to try to implement this functionality. Okay, so I'm sure that you got this. So of course we are going to use an if-else statement. So what we have to do here is to check if the score of the active player is now more or equal to 100 points. So once again we use our scores array, where all the scores are stored, and then retrieve the score for the active player and check if it's greater or equal to 100 points. So of course we cannot use just equal to 100 points, because that wouldn't be fair, right? Then a user with, let's say, 105 points would not get the chance to win. So it must be equal or greater to 100 points. And just to check if this works, we are going to display something on our web page, on our game, and we're simply going to replace this player 1 name here, or player 2, whoever wins, with the word winner. So the ID for this is name and then the active player. So document.querySelector. So the ID, name, and then our old trick again. So by now I'm sure this makes total sense to you. So again, text content. And now we will just say winner. And now in order to check this, I'm just going to put this down to 20 so that you don't have to watch me playing the game up until we reach 100 points. So I'm going to put this to 20 now just for testing, and then I'm putting it back to 100 later. So roll the dice, 15 points. And now if I hold, 15 plus 8 should already be more than 20, which is our winning score right now. So I should now be the winner. And yes, it works. Great. Now, what doesn't do much sense is that now it's the next player's turn, right? So let's change that with our else part of the if-else statement. So if the player wins the game, we want this to happen, and only if he doesn't, so if the game continues, then we want the next player to play the game. So let's copy this to here. Alright. So let's see this now. $12, $15, okay. Let's say if I can push this even more. Yes, so hold. And now player 2 won the game. So all we have to do now is to actually hide this dice here, I would say, and also remove the active class here from the current player, right? So let's do that, and it's not the first time we did this, of course. So we're doing it right here. So document.querySelector, and it's the dice class. So once again, we're going to change the CSS style. Display. We are going to set the display back to none. So now it will not be visible anymore. Now, one note about this way of styling our web page and changing the CSS. So it's not the best way to mixture or CSS with JavaScript. So if we have a lot of styles to change, we shouldn't do it this way. So we shouldn't really use the style property all the time here in our JavaScript code, but instead do it the way we did it, for example, down here in our next player function with the toggling or adding or removing classes. So instead of writing a bunch of lines here to manipulate the CSS, we should simply create a class in our CSS and then simply add or remove this class here in a JavaScript. And that's exactly why I created the active class that we have used already. And it's also why I created a winner class. So let's see this. So let me see where this is. Alright, so down here. So it's not a lot of CSS, but it's just to show you that it's always a better way to create a class like this instead of doing, for example, these two manipulations directly in CSS. So let's now apply the winner class to the entire player panel in order to make the winner look a little bit better, let's say. So these player panels here, so which are the entire left or right side of the user interface. So let's do that right here as well. So document.querySelector, and now the player that won this game is of course the active player, right? So only the player that is playing right now can win the game. So player, and then we use our trick with the active player, and then plus panel. So player 1 panel or player 0 panel. And now we use the class list again, such as we did before, to access the classes that this element has. And now we simply add the winner class, which is the one that I showed you before in the CSS. And what I should also do is to remove the active player class also from this panel. So I'm just going to duplicate this line, and then here it's not add anymore, but it's remove. So the active class. So remember, we have add, remove, and also toggle down here. So remember, what toggle does is to add the class if the class is not there, and if the class is already there, it removes it, which in this case is not necessary because we know that the winner class is not there, so we add it, and we also know that the active class is there, and so we remove it. So let's now check this out. Remember, I'm still at 20 points for the final goal. And here we go. So I won the game, and I'm no longer the active player, as you see here, as the dot disappeared, and also my winner score here is now red and big and bold. So this is already pretty cool, right? We've come a long way with this application and it's almost ready. There's still some problems because first, now if we continue hitting this button, we can still roll the dice, which doesn't make sense, right? And we also have this button here that we want to implement. So if you want to do that right now, then just hit that next lecture. See you there. So let's continue our coding journey. And we're getting really close to having our first real JavaScript application. So by now you have already learned a lot of stuff about DOM manipulation and even other things. So in this lecture we will just continue practicing some of these things and implement another feature in our game. Alright, this is where we left our game. So let's now implement this functionality here. So when we hit this button, that the game starts from the beginning. So if we have a button and an event, then of course we need to listen to that event. So once again, we will use an event listener. So let's check out the name of the button, and it's simply button new. So document.querySelector and button new. And by now you already really know how to do this. So add event listener, and once again we are listening for a click. And we will once again use an anonymous function here, which by now you know in your sleep, right, what this is. Okay, cool. So what do we have to do when we want to start a new game? The first thing that I can think of is that we have to reset our player scores. So we set our scores back to 0 and 0. And we also have to say that the active player is back to being 0, because that's always the player that starts, so the first player. And also if there is some round score left from the last game, so from the game that we were playing, then we also need that back to 0. So round score should be 0. Okay, so if this is starting to look familiar to you, then you're not the only one, because actually we already wrote that exact same code up here, right? So this is not ideal, not at all. So once again, we should stick to our dry principle here, so not repeating our code. So what can we do here? And you guessed it, once again we are going to use a function, and I'm calling this one init function, because this is to initialize the game. And the logic behind this is that once again we will write a function, and then even before doing anything else we will run that function, and this will then initialize or start our game. So not only when we hit a new game button, but also right in the beginning when we first load our application. So I'm going to delete this from here, okay. And I'm writing my init function now. So function, simply init, and again it doesn't receive any parameters. We just want to use this code. So I'm removing it from there and putting it right here. And then all we have to do is to simply call the init function right in the beginning. So the first thing that we do is to call the init function. And so that piece of code that we had here will then be run. Now the things that you see here are also things that are done right in the beginning of the game, right? So of course it also makes sense to include this right into our init function. So all the things that happen before we can start to play will now be placed right into this init function. So we call this function as soon as we load our application. But remember, we also want to call this function when we hit on our new game button, right? Okay, so we could do it like this. So we can simply call the function in here now, and that's it. But there's another way of doing this, because why should we create an anonymous function here, right? So this anonymous function only to then call another function. So it doesn't make much sense. Actually, as we set up our very first event listener, I told you that we can write any function in here, in this argument. So I'm just going to delete this, and what I can do now is to not call the anonymous function, but instead our init function. And actually I'm not calling it, I'm just passing it here into this event listener function, this method. And that's why I don't need to use the function call operator here, which is this one, because if I would, then this function would be immediately called, but I don't want that to happen. I just want to tell this event listener that, hey, when someone clicks this button, then please call the init function for me. So that's all that I'm doing here. So back to our game init function, which starts the game. Another thing that we have to do here is to actually change back the player names. So when someone wins the game, we print winner here. But when we start a new game, of course, we want to say player 1 and player 2 right there. So let's do that as well. And we know from up here, yeah, it's right here. So we know that these are called name and then the number of the player. And actually, let me just copy this from here, because by now we already know in our sleep how to do this, right? So we have to do this for name 1 and 2. So we don't need this active player variable here. So player 1, and now I'm simply duplicating it here for player 2. So player 2 here. And since we are using get element by ID for all of these IDs here, let me just do this here as well. So get element by ID. And now remember, we have to remove this hash symbol because this is only for the query selector. So this looks pretty cool. So let's now check this out. Alright, so let's roll the dice. Well, nothing's happening, so we probably have some bug somewhere. So let's open up the console. Alright, so we cannot say text content of null in line 93. So let's check out where that is. And of course, I did a big mistake here, right? And you probably already saw it coming, because the players are not 1 and 2, but they are 0 and 1. So of course I cannot set the content of an element called name2 if there isn't one on the page, right? So let's now load this. And yeah, so it actually works. So we already know that it works because before we had some different values here, not 0, 0, 0. But we see that our init function is already doing its work by setting everything to 0, just because we call it right in the beginning. So right here, before doing anything else, we call this function. So let's now play. Hold, and now player 2. And hold. And with this we can already win because remember, it's still set to 20. So I'm saying hold, and now I win. Cool. So now if I hit the new game, let's see what happens. Alright, so we are back to 0 points here and here. But what we still have is this winner class here, which formats this text red, and also the active class. So we need to do a couple more things in our init function. So first thing is to remove the winner class. Let me actually check where we put this winner class. Alright, so we put it here. So let me copy this to make our life a bit easier and just paste it here. Alright, so player 0, and this time I'm not making the same mistake. And now not adding but removing. And since we don't know who won the game, we will simply remove this class from both. So it doesn't matter, even if the class is not there, we can call the remove method without any problem. And actually we will do the exact same thing for the active class. So a class that defines or that shows which one is the active player. So again, of course, only one of these is the active player, but we have to remove it from both because we don't want any of them to be the active player. And now only one thing to left, which is to set the first player to the active player. So I will just duplicate this line and set it to add. Now this sounds a little bit strange, right? First removing it and then adding it. But I'm doing this because imagine that player 0 was the active player. Then in this case, the active class would be there. And if I then call this method here, so this line, then another active class would get added. And then we would have two active class, and of course we don't want that. Because if we later went to remove that class, then there still would be one left, and then the styles associated with the active class would still apply. And we don't want that. So we need to always remove them. And actually let me put this down here so that the ones that belong together are together. So we first remove these two so that we are sure that no active class is anywhere, and then we add the active class back to the first one. And with this, we should be good to go. So player 2 is in the lead this time, but I'm still rolling a lot of ones. Alright, so I'm going to let player 2 win. So I click hold, and alright, player 2 won. Everything looks nice. So now look at these numbers and at here when I hit the new game. Alright, so this works just fine. Everything is back to 0. Player 1 is the active player, the winner class is also removed, and everything is fine. So if I play again now, let me hold it here. Okay, so I won. Now, it makes sense that the game stops with this, right? But instead, if I continue hitting this, the game continues. And now we have 2 active players, and all of this is really weird and not working the way that it should be. So there's one more thing to do, and that will be in the next lecture. So if you're curious on how to solve this problem, then don't wait and come right with me. Now the time has come to finally finish up our application with only one small thing to do. So in this lecture, you will just learn what a state variable is, how to use it, and also why to use it. And this is really something about programming in general and not just JavaScript. So remember that the problem here was that we can continue to play the game even after we have a winner here. So this starts to look really weird and really not what we want. So we need something called a state variable. So what is a state variable? It's actually very simple. A state variable simply tells us the condition of a system. So that's the definition. And we need a state variable when we need to remember something or the state of something. And in this case, this will be, is our game playing or is our game not playing? So we will simply create a variable that tells us this and that we can then use in our function. Because there are, of course, a lot of things that we only want to do when the game is active, when the game is playing. So let's do that. And keep in mind that we want to use the variable in a couple of places. So imagine if we would just declare it here, like saying var game playing is true. Now, if we declare it here in this init function, then would all the other functions have access to this variable? And I know that you know that the answer is no, because of the scope chain. So all the functions do only have access to the global scope or of course the scope of their parents. So here the init function is really the only function that would have access to the game playing variable. So we need to define it outside, so right in the global scope. And that's also the reason why all of these are here in the global scope. So I'm just writing it here, game playing. Once again, I don't need to define it here, I simply need to declare it here. I need to say this is a variable that is defined here in this scope so that I can use it then in other scopes, in other functions. Okay, so when we start our application, the game playing variable will be set to true. So let's now work through our functions here to our event listeners one by one. So this one is for the event that happens when we hit our roll button. So we create a random number for the dice, then we display, and then we update the round score. Now we only want all of this to happen when the game is actually playing, right? Which means that we don't have a winner yet. And that's because the game playing variable will be false only after we have a winner. So after this weird situation that we saw before happens. So by then we want it to be false. But before, all the time during our game, we always want this game variable to be true. So what can we do here? It's actually very simple. All we need to do is to add an if statement here. So if game is playing, then we do something. And why does it work like this? So why do we only need the game playing variable here and nothing else? It's actually very simple. That's because the condition that the if statement wants here is a true or false value. And usually we use an operator here which returns a true or false value. For example, down here, we check if dice is different to 1, and this returns either true or false. But in this case, the game playing variable is already true or false, so we don't need anything else. Okay, so now all we want is to have this code right here. So all this code is now wrapped in this if statement. So all of this only happens if the game is actually playing. So after the game is finished, we can push this button as hard as we want and nothing's going to happen anymore because this will be set to false. So let's actually set it to false before we forget it. So what do you think is the perfect place to set this variable to false? I will give you a minute to do that by yourself. Alright, so I'm sure you figured it out. And so the perfect place to set this variable to false is here, right? So this is where we detect if a player wins a game. So after he won, which is this condition here, so when his score is greater than 20, which I still have to set back to 100, so right here, we will turn this variable to false. So we say game playing should be false. And that's it. That's all there is to this mechanism. Simply setting our state variable to false will avoid this situation here. Of course, together with this if statement here, right? Now, what else do we have here? Okay, where is the other event listener? Ah, yeah, it's right here. And once more, we also want all of this only to happen if the game is playing. So we can only hold our points if the game is actually active, right? So we'll do the exact same thing here. So if game playing, then do all of this stuff here. And of course there's not an else, because we don't want anything to happen if the game is not active. Alright, and that should be enough to make our game work perfectly fine. Eight, 11. Okay, now this player's turn. Alright. So we have a winner, we have 22 points, and let's see what happens if we try to keep rolling our dice. So, nothing happens. The game has effectively stopped. We can also not hold. And let me check if we have any bugs in our code. Actually no, so no bugs here. So it's not working because we blocked it with our code. So our if statement is really working, meaning that our state variable game playing is currently false. Now if I hit this new game button here, then remember the init function is called, and the init function sets our state variable game playing back to true. So now it should be working again, right? So let's hope it does work. And yes, it does. Great. So another winner, and again it doesn't work. Alright, so that's it. That's the end. This is your very first JavaScript application, and it's fully functioning now, and it's really working great. So now I hope that you're really proud of what we have achieved so far together here in this course, and especially in this really cool section. You can play this game with your friends and then tell them that you coded this by yourself. How cool is that, right? Really, just go play this game with your friends and let me know what they thought of the game here in the comments. I'm waiting for it, really. Alright, if you still haven't got enough of this game, then here come not 1, not 2, but 3 coding challenges just for you. So after finishing this game, I had 3 ideas about rules that we could change in this game. So I thought that these were 3 really cool challenges for you to do. So here they are. So the first one is that a player loses his entire score when he rolls 2 6 in a row. So not just the round score, but really all of his score. So 2 6 in a row, and then the player loses his entire score. And then of course it's the next player after that. And one hint that I can give you about this is that you should always save your previous dice roll in a separate variable so that you can access the present and the past dice roll at the same time. The second one is that you add an input field to the HTML where the players can by themselves set the winning score, and so they can change the predefined score of 100. And again, I have a hint. So in order to read the value from the input field, you can use the value property in JavaScript. And if you can't manage to make this working, then this is a good case for you to use Google to figure out the problem. This 100 here brings me to correcting what we still had here. So we still had 20, but of course the original rule was that the game ended at 100 points. Alright, and so the third challenge is to add a second dice to the game. And in this scenario, the player loses his current score when only one of them is a 1. And for this one, you are going to need some CSS and of course HTML to position the second dice. So if you have a hard time with that, then you can just look at the CSS code that I provided for you. And if you still can't manage to do that, to position the dice, then you can simply watch that part of the solution, right? So I really encourage you to do all of these 3 challenges, because this really allows you to get immediate practice with the coding, but also with the thinking about these solutions. So that's really the best thing that you can do right now if you really want to learn JavaScript. And that is why I designed these challenges for you. Okay, and after you did all of them, then you can just check the solution that I have for you in the next video. This is the first part of the solution for the coding challenge that I just gave you in the last lecture. So let's start by creating a new file which has all of this code so that we don't mess up our original code. So I select and copy all of this, and now I'm just creating a new file here. And this one will be called challenges.js. So I paste all my code here, and I will put these challenges at the top. Don't need this one here too. And we already know the game rules. Alright, so here are our 3 challenges. Actually, another thing is that now I have to comment out this part of the code and link our new JavaScript file to this HTML document. So script, source, and now challenges. Okay. So let's start with the first one, of course. So a player loses his entire score when he rolls 2 6 in a row. So as I already mentioned in the hint, we need a variable where we can store the previous dice roll. So let's do that. And of course, we are going to do that right here in the function which handles all of our dice number generation and displaying in the user interface. So our dice value is generated here. What I'm now going to do is to create a variable at the very end of this function, but still inside of this if statement that we added in the last lecture. So here I'm going to declare a new variable var last dice, and what I'm going to do is to set it to dice. So let me explain that. So we generate a dice number here, then we do all of this stuff, and then we check the dice number. So if we then store the last dice number, we can use that variable the next time that the function runs. But actually not yet, because this variable should not be declared here, but in a global scope. So let me simply create a new var here, last dice. And the reason for that is that once the function returns, so this function here returns, then the value of last dice will get lost if we only declare it in here. So for example, the value stored in this dice variable here will not be accessible to us after this function returns. But we need this last dice value the next time that someone hits the roll button. And that's because now, down here in our if-else statement, we are going to add another condition. So we want the player to lose his score when the current value and the last dice value are both a 6. So how do we do that? So dice must be 6. And now the Boolean operators are back. So the dice value should be 6 and the last dice should also be 6. And then player loses score. And then, of course, we still also want this part here. So else, and then the rest of the code that we already had. Okay, so once more, at the end of this function, we stored the value that we rolled with our dice in an external variable. So a variable that was defined outside of the scope of this function here. So we do that at the end of all this code here, so that the next time that someone rolls the dice, we have still access to that variable and can then perform this check here. When we just rolled a 6 and we rolled a 6 the last time, then the player loses his score. And if this does not happen, then we of course apply the logic that we had before. Alright, so how does the player lose the score? Remember, we use the scores variable, which is an array, to store these values. So all we need to do is to set it back to 0. And such as we have done all the time, we use the active player variable here to define which score it is from the first or the second player and set it back to 0. So that's really simple. And then of course we need to update the DOM as well, so that on our web page we see this value 0 as well. So instead of writing it all over again, make it a little bit quicker, I will just get it from down here. So now it's not scores. Well, we could actually leave this as it is here because scores active player is now 0, but we can also just set it to 0, right? Because we already know that that is the value. And what also happens then is that it's now the next player's turn. And so therefore we once again use our next player's function that we created before to apply the don't repeat yourself or dry principle. And now this should work. So let's come back here and refresh this. So let's try. Actually I should hold because otherwise there's no score to lose, right? Alright, so we see we lost some score here. We didn't see it because it was too quick. So let me try it again. Alright, so here we had it. Once again we lost the score here after rolling 2 6 in a row. It's not really visible in the video, but I actually clicked twice and there were 2 6s and we lost the score. And I'm sure you will experience that for yourself as well. So in the next video we have the solution for the second challenge. Alright, here goes the second part for our current coding challenge. So this time our task is to add an input field to the HTML where players can set the winning score, and then we can use the value of that in our code. So let's start by doing that, and I'm going to put it right down here. So what we need here is an input element. So input and the type of text. So text, we also want a placeholder here which tells us final score, and let's just call it with a class final score as well. Alright, so really simple. And now we also need to style it in our CSS in order to make it visible. And I will just put it here at the top. So the class selector and then final score. So this will be a bit of CSS. I'm not going to really explain this. I'm just writing the CSS that is necessary to style this, also based on the rest of the code that I already have here in this file. So this is a nice little technique to center it in a page. Translate x minus 50%. Okay, and from the top I want it at 520 pixels. The color is the same as the rest of the page. font size should be 18 pixels. And we also need to set the font family for this one, which is Lato in this case. We want the text in the center. And also some padding, let's say 10 pixels. And we want the width to be 160 pixels. And we also want a text transform of uppercase. So you see that I care a lot about design. So this really has to look the way that I want it to be. So let's now reload and see how this looks. So here's now our input field. Let's just remove this weird blue border here that we have when we focus it. So final score focus outline none. Okay, so now back to our JavaScript. And the question to ask here is, where are we actually going to use this value? So the value that the users write in there, the number, where are we going to use it? And the answer is, it will be in the part of the code which checks if the game has finished, so which checks if someone won the game. And this is exactly in a function associated with the event handler, which handles the event that someone clicks on the hold button. So it's right here. So right now we simply assume that the winning score is 100. But now we want to read this value from the input field and use that one. Let me just add it here in the code. So I'm going to call it input, very simple. So I'm going to select it using the query selector. We know that it's called final score. And now, instead of using text content or inner HTML or something like that, I simply use the value property. And this will give me the content that the user put it into this input field. And just to see how this works, let's console log this result to our console. So input. Alright, so let's now just check this out. I will reload this, open up our console. It doesn't have to be this big. Okay, and let's play the game and hold. And now we don't have anything here because this is empty, right? So if we continue playing, we will always have this empty here. So now it's twice the empty because we already clicked 2 times here on hold. Now let's put 50 here or something. Continue to roll the dice and click hold. And now it's 50 down here. Cool, right? So we can continue to roll and hold and then change this value to 200. Roll the dice, hold, and now it's 200. So the winning score by now would be 200. So the players can even change this during the game. Alright, so let's now use this value. So don't need this anymore, and alright. Now what happens if the users don't put any input into that field? Then we don't want to use the value, right? So we first have to actually check if there is a value. So we need to check if the input variable is not empty. And that's actually also pretty easy to do. And that's because, once again, type coercion. And I will actually write it down, which is that all the values of undefined, 0, null, or even the empty string, like this, are coerced to false. So if we have a condition like in an if statement, and I'm actually going to write it. So if we have something like this, so a condition here, then JavaScript will try to coerce this value here to a true or false value, so to a boolean. And in case that the variable that we have here is set to undefined, to 0, to null, or to the empty string, then these are coerced to false. And anything else is coerced to true. So if we would check this with something else, for example with the scores variable, so if scores, then this would return true, because it's not undefined, not null, not 0, and also not an empty string. In this case, the value of this input when the user doesn't put anything into the field is actually the empty string. So we only want to use this input if it's not an empty string. So when it's true. And down here in this if statement, we actually already have that. So if there is an input, so if input is true, then we want to do something. And that something is to create a new variable called winning score, in which we then store that input. And we need to do that because in the case that we don't have an input, we can store something else in that variable. So winning score is then the original 100 that we defined before. And so now instead of always using 100 here, we use the winning score. And of course this variable definition should not happen here, but outside from this if-else statement. So I'm just putting it here. And alright, here we go. So once again, when there is an input, which means that when the input is coerced to true because it's not the empty string, then the winning score will be set to the value that we just read from our input field. But if there is no input, then the winning score should be 100. And we can then use that winning score down here. So let's now check this in action, reload our page, and input a 10 here. So this should be a really quick game. Alright, and yes, it works, so we have a winner here. Nothing else works, so the game has finished as usual. And so we can now try this out with another value. So we could even start without anything, holding again, and then setting it to, say, 20 or 25. And we still don't have a winner. But now we should have. And yes, player 2 won the game. Alright. So challenge 2 completed. For solution of challenge number 3, just go to the next video. Finally, here goes the last part of the solution of our coding challenge. And this coding challenge is a really fun one, because this time we have to add another dice to the game, and then we will have 2 dices instead of just 1. So let's now do that. So the dice is down here, and I will just duplicate this line, and now we have 2 dices. And since they are different, we need a way to identify them both separately, and therefore I'm going to create an ID called dice1, and down here we will have an ID. And you can imagine that this will be dice number 2, right? And now just for the CSS, it's also quite simple because all I have to do is to position them. So I just need to specify their top. So top of this one will be 120 pixels, and then duplicating it, and 250 pixels for the second dice. And since they both share the dice class, all of these rules here appear to both. Alright, so let's, before we start coding, see how this looks. Actually, we cannot really see how this looks because one of the dice gets hidden, and that's because of the code that we wrote exactly to hide the dice. So maybe let's start by changing that code. So it's right here. So as I mentioned right in the beginning, probably in one of the first lectures of this section, the query selector only selects the first occurrence of the elements with this string here. So we could use the query selector all method here, and then we would have to use a for loop or a while to loop through the results. And we will do that later in the next project, but for now, let's keep things a bit simpler. And I will therefore just use the select element by ID method here. So I don't want this anymore. I'm just going to say document.getElementById, and the first one is called dice1, and I'm just going to set its style, or better, its display property to block, so that we can see it here. And the same thing for the second one. So we don't need this one anymore. And now, since this variable here is gone, I will also simply go ahead and replace this code with this part here. Okay, so dice1 will be the value of dice. Now, we still only have one dice value, right? So we need to fix that as well. So I'm going to create dice1 instead of dice, duplicate this line and create dice1 with the exact same formula. So if this runs twice, we already know that the math random always generates a different number. So these will be two different numbers. Not always, but generally there will be two different numbers. So now here it's dice1, and then duplicating this line, we will have dice2 here, and then the value of the random dice roll. Alright, and now down there, in the places where we actually hide the dice, now I will need to change that as well. So for example, in here, we have the dice. Now we need to put it to none for both. And the same thing here as well. None and none. Now maybe you're thinking, oh, I'm repeating a lot of code here. I could just create a function instead. And yes, that's true. You could actually create a function called hide dice, for example, and replace this code by that. And would actually make some sense. But in the solution of this coding challenge, I'm not going to do that. But of course, you can try it out and then see for yourself that it's going to work too. Okay, so here we are back. And actually, let's comment out this part here from the last challenge. Actually, this one as well. So we don't need this less dice thing, okay? Because what we want is only this, what we had before. Or let me just copy it from the original, okay? So it's less confusing like this. So we want the original part, so this. Okay. So this is what we had before. If the dice is different to 1, then everything happens normally. But now it's different, because now it's enough for one of them to be 1, and then we lose our score and the next player's turn is. So what has to happen that we can continue playing and that our score gets added? So the first dice, of course, needs to be different from 1, and at the same time, dice 2 also needs to not be 1. So this solves coding challenge number 3. And let's now test if this actually works. So in the beginning there's no dice, as we know. Now if I roll the dice, okay, so here we have now 2 dices. But there's still one problem, because here we don't have a number right now. So actually the problem is not yet solved. So let me look at the console here, and there we have an error. And an error happened in line 32, where we see that we still were using the old dice value. And actually, yes, we did. So of course we don't want the dice here anymore. But now what gets added to our score is not only dice 1, but of course the sum of these two. So dice 1 plus dice 2. So that's what we're missing here. So closing this, and once again, roll the dice. And yes, now 4 plus 2 is 6. Hold it, and the next player, oh, and he once again rolled one of them was a 1, so it's right back to player 2. So yeah, this was challenge number 3 with 2 dices. So we did 3 nice changes here, which hopefully helped you get a bit more practice with your JavaScript. Alright, so see you soon. Hello and welcome back to the next section. Let's now take a deep dive into the most advanced topics in JavaScript, and that is objects and functions. So objects and functions are 2 closely related concepts in JavaScript. They are also the 2 most used features of the language, because they allow us to do so many advanced things with our code. And so it's absolutely vital that you get a good grasp of everything about objects and functions. Now, some of these concepts may be kind of difficult to understand and confusing in the beginning, alright? But don't worry, that's absolutely normal when you're first confronted with these topics. So just pay good attention, take some notes, and maybe rewatch a lecture or two if that's necessary. And if you do so, well, I can guarantee you that objects and functions will be crystal clear after this section. And with that being said, let's now get started with a deep dive into objects. In this lecture, we will take a closer look at objects in JavaScript. We will talk about object-oriented programming in general, inheritance, and how JavaScript handles objects and inheritance through prototypes. This is probably one of the most important lectures in this course, if you really want to understand JavaScript. So, there's a saying in JavaScript which says that everything is an object. And while this is almost correct, it is not 100% correct though. Because in JavaScript, we have two big types of values: primitives and objects. And primitives are all the values that have one of the data types that we talked about in the intro lectures. So numbers, strings, booleans, undefined, and null values, all of these are primitives. And everything else are objects. And that's why in JavaScript we say that everything is an object. And in fact, even simple things like functions, arrays, or dates are all objects in JavaScript. And that's because in JavaScript, objects are not just for storing a bunch of data, like we have been doing, but for really complex things under the surface. So we have been using objects all along, just without knowing it. So always remember that almost everything is an object in JavaScript, because it's one of the fundamental things that makes JavaScript so unique and different from other popular programming languages. Alright, so now that we know how important objects are in JavaScript, let's look at object-oriented programming. So, in very simple terms, object-oriented programming makes heavy use of objects, properties, and methods. And these objects interact with one another to form complex applications. We use objects to store data, structure our code, and keep our code clean. So far, we have only created simple objects holding some data. I remember the John object from the intro lectures. And if we had created other persons back then, we would simply have written them one by one, like Mark, Jane, etc., right? But there is a better way. Imagine something like a blueprint from which we can generate as many objects as we want. And we can do that in JavaScript. And right here is an example of that. This is a special person object that we can basically use as a blueprint to create a lot of person objects. In other programming languages, this is many times called a class. But in JavaScript, we like to call it a constructor or prototype. So based on this constructor, we can create as many instances as we want. So here are our Jane, Mark, and John objects once again, but these were created from the person constructor. So they are effectively person instances. And now their name, year of birth, and job variables are defined. And they all have access to the calculateAge method. So again, the constructor acts like a blueprint and is used to create instances, which of course are also objects. We will of course do all of this with code over the next lectures. This is just to give you a very brief overview. And now let's take this even one step further, with inheritance. In simple terms, inheritance is when one object is based on another object. It's when one object gets access to another object's properties and methods. So very simple. Back to our persons example, imagine that we also wanted to have an athlete constructor besides the person constructor, with a couple of different properties and methods. Now, an athlete is also a person, right? There are just some particular properties and methods for an athlete, like for example, how many participations in Olympics they have or how many medals they have won. So when we define the blueprint, so the constructor for an athlete, then why repeat the same stuff that we have in our person constructor? An athlete also has a name, year of birth, and job, right? So what we can do is to use inheritance. We make the athlete object inherit the properties and methods from the person object. So then, the athlete not only has access to its own properties and methods, but also the ones from the person object. Really cool, right? This allows us to write less code and make more logical programs. So this is a broad overview of how inheritance works in theory, and in all programming languages that have object-oriented features. So let's now see how JavaScript in particular handles inheritance with our person and John examples. JavaScript is a prototype-based language, which means that inheritance works by using something called prototypes. In practice, that means that each and every JavaScript object has a prototype property, which makes inheritance possible in JavaScript. So again, inheritance is made possible through the prototype property that every object has. Now all of this may look a bit confusing at first sight, but don't worry, because we will do everything in code later as well. But before doing that, it's super important that we get at least a visual overview of what happens behind the scenes. Alright, now how does inheritance actually work? To better understand this, let's go back to our person example, where the person object is the constructor and John is one of the instances. Now, if we want John to inherit a method or a property from the person object, we have to add that method or property to the person's prototype property, just like we see it here. So in this example, we have the calculate age method in the person's prototype property, and therefore John inherits the method and can then call it. And any other object created by the person constructor would inherit this method as well. So again, the prototype property of an object is where we put methods and properties that we want other objects to inherit. What is really important to note here is that the person's prototype is not the prototype of the person itself, but of all instances that are created through the person blueprint, like for example John. So in other words, the person's prototype property is the prototype of John. And that's not even all, because the person object itself is an instance of an even bigger constructor, which is the object object. Yeah, that sounds a bit crazy, but this is actually how it works. Each and every object that we ever create is an instance of the object constructor, which has a bunch of methods in its prototype property. And as you can guess, the person object inherits these methods and can call them. Plus, the John object also inherits these methods and can also use them. And with that, we have actually explained the prototype chain. So, the prototype chain is what makes all this inheritance possible. And here is how it works. When we try to access a certain method or property on an object, JavaScript will first try to find that method on that exact object. But if it cannot find it, it will look in the object's prototype, which is the prototype property of its parent. So it moves up in the prototype chain. If the method is still not there, this continues until there is no more prototype to look at, which is null. Null is the only one that has no prototype, and is therefore the final link in the prototype chain. And in this case, undefined is returned. This is the reason why, for example, the John object could call the hasOwnProperty method that is stored in the object prototype property. And since this is all so crazy important, I even took the time to write down a summary for you about the most important things about prototypes, so that you can copy it if you want. So here it goes. Every JavaScript object has a prototype property, which makes inheritance possible in JavaScript. The prototype property of an object is where we put methods and properties that we want other objects to inherit. The constructor's prototype property is not the prototype of the constructor itself, but it's the prototype of all instances that are created through it. When a certain method or property is called, the search starts in the object itself, and if it cannot be found there, the search moves up onto the object's prototype. This continues until the method is found, and this is the prototype chain. Alright, so this is it about objects, inheritance, and prototypes in JavaScript. I promise that we'll now finally go back to our code. Let's now finally write some code to use the concept that we talked about in the last lecture. And I will start by opening up the starter project that you can download for this section. And once again, it's on our desktop already. So I just need to open it. And here we have the HTML file, which connects with our script. And here's just the empty file. Alright, so this lecture will be about creating objects using the function constructor. So I'm just writing it here to structure our code better. So I'm going to start by writing our well-known John object, right? So John with the name of John, of course, and the year of birth. And then our job. So this is the way that we have been writing objects using the object literal, right? And now imagine that we wanted to create a lot of objects with different names and ages and jobs. So as we learned in the last lecture, we can use some kind of blueprint for this, right? So in JavaScript, there are a couple of different ways to create objects. But probably the most popular way is using something called a function constructor. And this is a very common JavaScript pattern. And the pattern is something like a standard way that we have to solve a problem always in the same way. So the function constructor is a pattern for like writing a blueprint, such as we have been talking before. So the name function constructor implies that we're going to use a function here, right? And we want this constructor to be called person. So we create a function called person, and the usual convention in JavaScript is that we always write function constructors with a capital letter here, right? So person is with a capital P, okay? And we always do this for function constructors. Alright, so function and the parameters for this function constructors will be the variables that we want to set in our object. So in this case, it's going to be name, year of birth, and the job. And now I'm just going to show you how this is done, and I will explain to you why this works just in a second, okay? So what we do is to attach these variables, so these arguments, to the this variable of this function's execution context. So just like this. So this.name, and remember that the this variable is simply an object as well, so we can do it like this. So this name will be name, which means the one that we get here as an input for the function. So this dot name will be equal to name, which is the parameter of the function, and then the same thing for the other two. So this dot year of birth will be equal to year of birth. And then this dot job will be the job that we pass into the function. And that's it. This is the function constructor. And again, I will explain to you why this works in a second. Alright, and now that we have this function constructor in place, we can then use it to create a John object. So let's create some space here, and then var John, we call new, and this is the new operator, new person, and then we pass our arguments into the function. So we already know our arguments, so 1990, and then the job teacher. So this is how we create new objects using the constructor function. And this is called instantiation, because these objects here are instances of the person object, as we learned in the last lecture. Alright, and as promised, I'm now going to explain you how all of this works. So first, in order to understand how this works, we need to first understand what the new operator does. So when we use the new operator, first a brand new empty object is created. Alright, so an empty object, this is important. Then after that, the constructor function, which in this case is person, right, is called with the arguments that we specified. Okay, so first an empty object is created, and then the function is called. So, and as we already know, calling a function creates a new execution context that also has a this variable, right? Now, we know that in a regular function call, the this variable points to the global object, right? But if we now look at our function constructor here, then having the this variable pointing at the global object wouldn't be so useful, right? Because like this, we would simply set all these properties on the global object. And that's of course not what we want. And that's why the new operator takes care of this. And it makes it so that the this variable of the function points to the empty object that was created in the beginning by the new operator. Remember that? So again, what the new operator does is to point to this variable not to the global object, but to this new empty object that was created in the beginning when we used this operator. So then after that, when we set the name, year and job properties to this, then that's the same as setting them right on our new empty object. Okay, and finally, if the constructor function does not return anything, and as you can see here that is clearly the case, then the result is simply the object that was created in the first step. So this new empty object here. And this empty object, which was created here, now has the properties that we defined. So the name, year of birth, and job in this case. Okay? And then finally all of this is simply assigned to the John variable. And just like this, we created an object called John simply by calling a function constructor. So again, our new operator here first creates an empty object, then it calls our function with the this variable not pointing to the global object, but to the new object that was created here. And then when this code here runs, the this variable is no longer the global variable, and so these are all set on the new object, which is then in the end assigned to this variable. So I hope that makes sense. So let's now add inheritance to the game. And for that, we are going to bring back our calculate age function. So let's now suppose that we wanted to add a method to our objects. And that sounds easy, right? We could just add it to our function constructor like we would do with a normal object. So just like this. So this dot calculate age, it's simply a function which logs to the console the age. So 2016, we already know this by now, minus this dot year of birth, right? And now we can actually use this, and it should of course work. So John.calculate age, and let's now open this. And that's not what I wanted, so here we are. And in a console, and what's this here? Oh, it's nothing special. So now it's alright. So 26 is our expected outcome here. So everything works just fine. So let's now create a couple of more objects here for more people. So var Jane is also a new person, and this is going to work the exact same way, right? So now I say Jane was born in 1969, let's say, and she's a designer. And it will also create Mark, so a new person called Mark, obviously. He was born in 1948 and he is retired. So if I now run this, then each of the object that is now created has the calculate_age method attached to them, right? Because it's right here in the constructor function or the function constructor of all of these three objects, right? So again, each of these objects now has the method. Now in this case, it's just one function with one line of code, so this is no big deal. But now imagine that we had 20 functions in each object and that each of them would have 100 lines of code. Now that would not be very efficient, because then we would have 3 copies of the exact same thing, right? And that is exactly why we use inheritance, in the exact same way that we have learned in the last lecture. So what exactly did we learn in the last lecture? So we've learned that we have to add all the methods and properties that we want to be inherited into the constructor's prototype property. And that sounds difficult, but it's really not. So let's just do this. Just creating some space here, and I will actually do it here. So all we have to do is to say person.prototype, because as I was saying, it's simply a property. So all we have to do is to use the dot and then prototype, and then we can add our function there. So calculate age and then our function. And I can actually copy it from here because it's the exact same code. Okay, and now I'm going to remove it from here. So right now, if I reload this, effectively none of the objects have the calculate_age method really attached to them, but still they are going to be able to use it. They will have access to it because it's in their prototype, right? So let's prove that. So I'm going to put all of these together and then call these methods on all of them. So calculate_age for Jane and also for Mark. Calculate_age. And if I now reload this, here is the result. So all the 3 ages for all the 3 people. So again, the method is not anymore in the constructor, right? But we can still use it. And that's because it's in the prototype property of our function constructor. So inheritance actually works, and this is inheritance in practice. So this is really great, right? This is so powerful. You just really understood how this works and how it works behind the scenes. So you can not just use it, you can also understand why this works. And this is really extremely powerful, and it's really great for you. So attaching methods to the constructor function's prototype property is something that is really common to use. We can of course also add properties instead of methods, but that's not really common, but I still want to show it to you, okay? So such as we did with the method here, we can do the same with properties. So once again, person.prototype, and now we can say, for example, a last name property. And we can say that they should all be called Smith, right? Because as we know, this will be inherited for all of them. And once again, I want to prove that to you. So let's console log this property. So first for John dot last name, and then for the other 2. So console.log Jane.last name, and then Mark.last name. So let's see what happens. Okay, so all of them are called Smith. So once again, this property is not directly in the object, right? But we have access to it because it's in the prototype property of the function constructor. So all John, Jane, and Mark inherit this property. So once more, we proved that inheritance really works. And this is a really big deal So if you understood this lecture and the last one, then you are well on your way to become a really great JavaScript developer. What I want you to do now is to create your own type of objects to play around with constructors and prototypes a bit. And this way you can consolidate what you just learned here. So I hope that sounds like a great idea for you. And then after that, let's go straight to the next lecture. The JavaScript console in our browsers is a very powerful tool to inspect objects and a prototype chain. So let's now quickly see how we can do that in practice. So I'm first going to show you how we can inspect the object that we just created in the last lecture right here in the console. Because the console is not just to log some stuff here into our console, like we've been doing, but also to do more powerful stuff, like inspecting objects. So let's first clear this, alright? And now we simply have to write the name of our object. So you see, this is a person object, and then our name, year of birth, and job. But now if we hit this little arrow here, then we get a lot of additional information about the object. Alright, so first here we can see all the properties that we added to this object. So the job, the name, and the year of birth that we associated to this very particular object. So everything is correct here, right? Now down here we have something called the proto. And this is in fact the prototype of the John object, which is, and I'm sure you remember this, the prototype property of the person constructor. So let's take a look at that. Okay, so here we have the calculateAge method that we added to our prototype here, right? So here we said person prototype calculateAge, and so we can see the calculateAge method here in the proto, which again is John's prototype, and therefore it's the prototype property of the person function constructor. And we also have the last name property that we also added. So let's also quickly take a look at person.prototype. Okay, and let's get some more space here for our console. So we see that this is in fact the exact same thing, right? This and this. Here it looks the exact same way. And just to prove you that John's prototype is in fact the prototype property of the person, I can actually do it like this. So proto, and then let's see what this comparison operator now is going to give us. Okay, true. So all this means is that in fact the prototype of John is the prototype property of the person function constructor. But I'm sure that you know this already by now. So let's go back to our John object here. And actually I'm going to clear this and write it again. Alright. So this is the proto. Now if we look at the prototype of John, we see that there's also a prototype here, right? So let's open that. And here we see that this is the prototype property of the object constructor. So as I said right in the first lecture about the prototype chain, all of the objects are actually instances of the object, right? So let me open this again. Okay, and so here we have a bunch of methods that are associated to the prototype property of the object function constructor. So again, this one here is the prototype property of the person function constructor, and this here is the prototype property of the object function constructor. And that's because the person function constructor is in fact an instance of the object function constructor, right? And that's why we can see this whole prototype chain here, right? So as I said, this console here is really useful to visualize this prototype chain and all of the prototypes that are in it. So as we already know, we have now access to these methods here, right? And that's right to our John object. So thanks to the prototype chain, on John, we can use these exact methods that are here. And now I'm going to use the hasOwnProperty method just to show it to you, because it can be useful sometimes. So we can use this method to ask basically if an object has a property or not. So we can do John dot hasOwnProperty and then job, for example. And this is true because this object has a property called job, right? Now, if we try this with the last name property, then it's going to give us false. And that is because this is not John's own property. So this method only looks for own properties. This is a property that we inherited from the prototype. It's not really John's own property. And that's why this gives false. And this method can sometimes be quite useful. And now there's another operator that I want to show you. And this one is called instance of. So I'm going to say John instance of person. And this is also like a question because it will also give us true or false. And in this case, you can probably guess that it's going to give us true. So John is of course an instance of person because we created it through the person function constructor. And this one can also be useful sometimes. Okay, and with this we inspected our John object and the prototype chain that we just created. Now there's only one more thing that I want to show you, and that is to prove you again that almost everything is an object. So let me create an array here, just like this, just a very simple one, and let's now get some information about it. So if we just hit X, not a lot is going to happen. We cannot inspect this object right now. So we need to use console.info, and now we will be able to look inside of this object. And this is what we see. So we see the elements, and then we also see this length property here, right? And do you remember this length property? We use it all the time, for example, in our loops, right? And so now you know where this actually comes from. It used to look a bit like magic, right? But of course it's not. So it's always stored right here in this array instance. And that's why we can very simply use this property. So something like this. So x.length is 3, simply because this is stored right into this array object. Alright, and it gets even better because down here we can also see the prototype of this array, which of course is the array function constructor. So this is another function constructor that is built right into JavaScript and allows us to simply build arrays. And here in its prototype property, we can see all of these methods that we have already used before, like pop and push here, right? Or we used unshift as well. So all these methods are right here in the prototype property of the array. And that's why we can use them. So did you never wonder why we could simply call the push method or something like this on all of our arrays? So now you know, it's because of the prototype chain. So all the arrays that we ever create will always have access to these methods because they are stored in their prototype. And that is how useful inheritance really is. So I hope things are really starting to make sense for you now. So let's now move on. In this lecture, we will talk about another way that we can create objects that inherit from a prototype, and that's the object.create method. So we have seen the function constructor pattern to create objects from a blueprint in the last 2 lectures. But there are more ways to create objects and inheritance. So let's talk about the object.create method now. And let's first comment out this code here. Okay. So this is object.create. Alright. So with the object.create method, things work a bit different. In this case, we first define an object that will act as the prototype and then create a new object based on that very prototype. So let's do that right now. And we're going to recreate the person example that we used for the function constructor lecture. So first we have to write the prototype as a simple object. And I'm going to call it person_proto. So person_proto, and now you see we no longer use the capital P in the beginning because it's not a function constructor. And what I want in the prototype, such as before, is the calculate age method. So we already know why and how inheritance work. Now we're just doing it in a different way. Instead of using function constructors, we will do it the object.create way. So it's simply a different way. Alright, so calculate age and function. And again, I'm going to console log it 2016 minus this dot year of birth. Now there is no year of birth here anywhere, but we're going to take care of that later. Okay. And now let's create John again. So we simply say object.create, and then we simply pass it the object that we defined to be the prototype object, which will be person_proto. Okay, so let's see this in the console. Alright, and I'm not gonna console log this, so I will just do it the way we did before in the last lecture. So John, and here is the object. And now it's empty, there's nothing here, right? But we still have the prototype, and this already has our calculate age function. So this looks a little bit like before, doesn't it? Now we just have to fill this John object here with our data. So we can simply do it the old way, right? So John.name is John. John.year of birth is 1990. And John.job is teacher. And if I reload this now and say John, then here we have our object. And it looks a lot like it did before with the function constructor, right? So we have our data here, the job name and year, and then the prototype, which contains our calculate age function. However, it was not ideal the way that we had to fill this here, right? So the object that we created was empty, and then we had to fill it here with the data. So this time we're going to do it a different way because the object.create accepts a second parameter. So let's now do that for another person. So Jane, object.create, and of course the prototype is again person_proto, but then we can pass a second argument, which is an object specifying the data that we want to have in the object. So name, and now we cannot simply put the name here, but we have to do it in this rather strange way like this. So we have to say value, and then we can say Jane. Okay. So this looks a bit strange, but it's actually how it works. So there's no way around doing it like this. So year of birth, and then again value, and 1969, and then the job, and once again value, and then designer. Okay, and let's now reload this, and John again, and Jane. So both share the same prototype, as you can see here, because both have the calculate age method, and then they have both their own type of data in there. Okay, so let's think about this again. The difference between object.create and the function constructor pattern is that the object.create builds an object that inherits directly from the one that we passed into the first argument, While on the other hand, the function constructor, the newly created object inherits from the constructor's prototype property, right? So that's the big difference. And I hope this makes sense to you. Actually, one of the biggest benefits of object.create is that it allows us to implement a really complex inheritance structures in an easier way than function constructors, because it allows us to directly specify which object should be a prototype. Alright, so function constructors and object.create will be the most common ways of creating objects that you will find the most when you're looking for tutorials on the web. And that's why I showed you both in this course. But the most popular though is still the function constructor. And so that's the one that I'm going to use mostly in the rest of this course. Before moving on from the topic of objects to the topic of functions, I just want to very quickly compare primitives and objects. We actually talked about this very briefly at the beginning of this section, but then we were too busy talking about the prototype chain and those important things. But let's get back to it now. So let's get first rid of this code here. All right. So, primitives versus objects. And we basically know that only numbers, strings, booleans, undefined, and null are primitives, and that everything else are objects. And we already know a lot of differences between the two, so let's now compare them even more. So, a big difference between primitives and objects is that variables containing primitives actually hold that data inside of the variable itself. On objects, it's very different. Variables associated with objects do not actually contain the object, but instead they contain a reference to the place in memory where the object sits, so where the object is stored. So again, a variable declared as an object does not have a real copy of the object, it just points to that object. So let's see this in practice. And I'm going to start with primitives. So let's define a couple of variables. So let's simply call it a and set it to a random number. And then let's create variable b and say it should be equal to a, okay? So b is now also 23, right? And now I'm going to mutate a, which means to change its value, and I'll change it to 46. And let's now simply console log a and b. A and b. So 46 and 23, that's what you expected, right? So a is 46 because we changed it from 23 to 46 here in this line, and b is 23 because up here we said that b should be equal to a, right? So what we did here was to simply copy the value of a to b. And when we then changed a to 46, this did not affect the value of variable b, which still is 23. And this means that each of the variables actually hold their own copy of the data. They do not reference anything. So two variables holding primitives are really two different things. So let's do something similar with objects this time. So obt1, so this is our first object named John, and then just set the age to 26, okay? And now something very similar, I just say object2 equals object1, okay? Such as we did before with b equals a. And now I'm going to mutate the age on object1. So .age, and I'm going to change it to 30. And then let's console log the age on object1 and duplicate this line and object2. All right. So we have a small bug here, all right? So because this should be object1, of course. Right, so what happens now? Okay, they are both 30. So object1.age and object2.age are both 30. And that's really strange, right? Well, not really actually. And that's because when we said object1 should be equal to object2, we did not actually create a new object. No copy was created here. All that we did was to create a new reference which points to the first object. So the object1 and object2 variables both hold a reference that point to the exact same object in the memory. And that's why when we change the age on object1, this change is also reflected on object2, because in fact it's the exact same object. So this is some really interesting stuff, right? It took me some time to actually understand this. Now with functions, it works in the exact same way. So let's see what happens when we pass a primitive and an object into a function. So let's create some space here. Objects, these were the primitives. And now functions. So I'll start by creating an age variable. Okay, and then another object. And this time it's not going to be John, this time it's me. So Jonas. And I will say the city, and that's Lisbon, so the city where I'm currently located. And now we write a simple function, which I'm just going to call change, and it receives two parameters, a and b. And all this does is to mutate the data. So we want a to be 30, and we want b dot city to be San Francisco, for example, because it's a really nice city, you know? So now we're going to call this function, and as you can guess, we are going to pass age as the a variable, so as the a argument, and the object as the b argument. Okay? And now, once again, we will simply console.log the result to the console. So the age, and then console.log obj.city. So what do you expect is going to happen now? And let's see. Okay, so 27 is age, and this object city, so the city attached to the object variable, is San Francisco. So we have the same thing here. We pass the age variable holding a primitive and the object variable holding a reference to an object into our function. This function then, as it was invoked, attempted to change the arguments that we passed into it. So when we then console log the values, we see the same thing as before. And that is that the primitive has remained unchanged, but the city in the object has changed from Lisbon to San Francisco, with this line of code here, right? So this shows us that when we pass a primitive into the function, a simple copy is created. So we can change a as much as we want, it will never affect the variable on the outside, because it is a primitive. But when we pass the object, it's not really the object that we pass, but the reference to the object. Okay? So again, we do not pass an object into a function, but only the reference that points to the object. So when we then change the object inside of the function, it is still reflected outside of the function. So I hope that this shows you that it's really something very important that we should really be careful about, right? Because this can lead to some unexpected results and some strange bugs. And that's why it's super important that we have this information now. Cool. So let's now go to the next lecture right now. Now that we have learned a lot of new stuff about objects, let's switch to another topic, functions. And actually, it's not a completely unrelated topic, because we already know that functions are also objects. And that being said, it makes sense that with functions, we can do the same things that we can do with objects. So let's see some facts about functions. First, as we already know, a function is an instance of the object type. And because of that, a function behaves like any other object. We can store functions in a variable, and we already know that. And we can pass a function as an argument to another function. And we can also return a function from a function. And because of all that, we say that in JavaScript, we have first-class functions. So let's see a real-world example of how functions can accept other functions as arguments. And actually, we already did this. Do you remember the pick-game project that we coded before? We set up some event listeners back then, right? And we passed a function into each one of them in order to handle each event. So back then, we already used first-class functions, but we didn't just know it. Alright, so let's now imagine that we have a couple of arrays filled with values and that we wanted to do some calculations with them. And a birth year array could be a good example of this. So let's write an array with some years in it. So 1990, 1965, 1937. I'm just going to write 5 numbers here, so 5 years. 2005 and 1998. Alright, so 5 years. So remember, we want to do some calculations with these values, or based on these values. Now, we could do a huge function which does all of these calculations that we want to perform at the same time, and then results all the result arrays at the same time. But that would not be really good practice, because instead, we can write a function that will receive an array and return a new result array and do the calculations based on a function that we pass into the calculation function. So let's write that calculation function and call it arrayCalc. So function arrayCalc, and what we're going to pass in here is the array, which will be, for example, the years array, and then we will pass a function which does the actual calculations. So let's see what this function does. So in here, we will simply loop over the array and return a result. So the first thing is to create a new empty array, which will be the one that we're going to fill and then return. So var r for the result. So I'm just going to say res here. And it's an empty array. Alright, and do you remember how we loop over arrays? So we've always been doing it using the for loop, right? So let's continue doing it this way. So we set up a new variable I, which is our counter, set it to 0, and then loop as long as I is smaller than the length of the array that we input, right? And by now you already know how this length property works, right? And then after each loop, we increment our counter by 1. Okay, and so down here, inside of the loop, we will then use the function that we can pass into this function. So we will push something into our result array here, right? So we can do it like this. We use the push function, or the push method, to be correct, which, as you remember, inserts an element at the end of an array. Okay, so the big question here is, what are we actually going to push into the array?